All right, so the goal in this lesson is to be able to use the trapezoidal rule to help approximate a definite integral. Now, like what's the point of this? Why do we need to use trapezoidal rule if we can just use the fundamental theorem of calculus? That's easier. Well, the issue is there's actually going to be some functions that don't have antiderivatives. So if you want to integrate, like for example, any of these, you just couldn't do it by using the fundamental theorem of calculus because you can't find an antiderivative. And so now you're stuck. It's not going to be a simple formula. So let's just remember like the general principle of a definite integral. It's essentially going to be the area of the function from the endpoints from A to B, whatever those are. And this is going to be similar to what we did early in the chapter when we calculated the Riemann sums, where we had a set of rectangles and found the area of those rectangles, and to get an idea of what the total area of the function would be from one point to another. In this case, though, we're going to focus on using trapezoids, and we use trapezoids because they're actually going to be more precise. Now, let's go through like a elementary proof, and this is not going to be like a formal rigorous proof, but I think this is important for you guys to conceptualize how this trapezoidal rule works instead of just jumping to the formula and trying to apply it with like calculation, and especially if you're going to be taking the AP exam, you're not really going to have problems where you can simply plug and chug the formula in. I'm going to explain why in a few minutes when we get there. Let's first look at this. So let's say we want to get the area from A to B underneath this function, and we have these 4 trapezoids, you see? We got 4 trapezoids. So the definite integral from A to B of f of x dx will be approximately equal to this area. We'll call this A1 plus A2 plus A3 plus A4. We add up those areas of the 4 trapezoids, and we can get approximation, what's going on with this pen, of the true area. Okay, so how do we do this? Well, let's first review the area of a trapezoid. Maybe it's been a while. Probably just covered that in middle school. Remember, a trapezoid is basically a 4-sided figure, with one set of parallel sides. So this could be a trapezoid. Now remember, the parallel sides are called the bases. So we'll call this one base 1. This one be base 2. And to find the area of a trapezoid, we'll take the average of the bases multiplied by the height. But remember, the height has to be the length of a perpendicular segment. So the length of like this would be the height, for example. The length of this perpendicular segment would be the height of this trapezoid. And so the area would be B1 plus B2 over 2 times the height. Now, so how do we apply this to this? Because what I've noticed that students will initially get confused about is like, well, how are these trapezoids? They'll think of the trapezoid as this being a base and this being a base, and the sides being the heights. That's wrong. I'll just tell you that's wrong. Don't make that mistake, because this is going to make this entire chapter or section very confusing. This is not the base. These are not the heights. These are actually trapezoids, but think of them being stacked, in other directions. The heights are going to be these lengths, and the bases will be, this will be like, we'll call this one B1, call this B2, So B3 we'll say, B4, and B5. So we have 5 bases for those 4 trapezoids. And the heights, since this is uniform, are, all the same, the distance from here to here, because these are the right angles. That's the first thing you want to make sure that you don't confuse. So again, in other words, you can have a trapezoid that's, that already has a height as, and one of the sides, is perpendicular to the trapezoid. So that'll be like this. The height is already, it's linked to this side, but you still have B1 and B2 like that. Except these are stacked, these are just stacked on their, heights, essentially on their sides, so to speak. Now, so all we have to do is find out the pattern for the areas of these trapezoids. And it's actually simple algebra once you get the idea. So let's focus on A1. A1, the area will be B1 plus B2 times the height. Or sorry, B1 plus B2 over 2 times the height. B1 and B2, how do you find those? Well, these are going to just be the values of y at these coordinates of x. Because this will just be, remember, this will be the point x0, f of x0. This point over here will be x1, f of x1. So then the area, the base B1 and B2 will be f of x0 plus f of x1 over 2. And the heights, this will just be, remember, our delta x, or b minus a divided by n, depending on how many trapezoids we'll have. Remember, delta x, remember, if we have a uniform set of trapezoids, all their intervals are the same length, so b minus a over n, so just be the same thing as the heights. So we're going to have b minus a over n. That's the idea to get the area of A1. So if we just apply this to find the other areas. A2, is B2 plus B3 over 2 times height. A3 will be B3 plus B4 over 2 times the height. And A4 will just be B4 plus B5 over 2 times the height. Heights are always going to be the same. Will it just be b minus a over n? Well, that's not an issue. And B2, we already found B2, which is f of x1. Now B3 will be this point here. It'll be at x2 f of x2. Shouldn't, it's a little messy, but so this will be f of x1 plus f of x2 over 2 times again b minus a over n. And we essentially keep on applying the same idea. A3 will be f of x2 plus f of x3 over 2 times b minus a over n. And then A4 will be f of x3 plus f of x4. Over 2 times b minus a over n again. So we add all these up, and we'll get the approximation for the area of that integral by adding those four trapezoids up. So this is a general concept behind the trapezoidal rule. You're going to notice a pattern. We only did 4, but you can see that some of the bases repeat because A1 both A1 uses B2 and A2 uses B2, A2 uses B3 and A3 uses B3, A4 uses B4 and A3 uses B4. The only ones that aren't used twice are B5 and B1, which are the endpoints. They're also all multiplied by the same height, so you can actually factor these out in the formula. So, again, you would factor out b minus a over n as well as a 2. So you can actually factor out b minus a over 2n for all of them. And all you would have is then f of x1 plus f of x2 plus f of x1 plus f of x2 plus f of x2 plus f of x3 plus f of x3 plus f of x4. And it's actually going to then be shown that this formula will calculate the sum of n trapezoids for some function, as long as the trapezoids are uniform, so same width. Let's actually put a note here. For uniform. Now, when I say uniform, that's assuming that we're going to divide the integral or the integral from b to a into equal, widths, I guess, if you look at it in terms of x, or technically the heights, they'll all be the same. Now, the thing is actually on the AP exam, usually they're not uniform. Let's put a note over here. On AP exam, trapezoids are usually not uniform. So they're not usually going to be the same heights or the same widths. That's why I don't recommend you, and I try to drill this into my students to not just memorize this formula. So remember, this is not a course where you just want to show you can do algebra. This is just algebra. This is just an algebra calculation. It's not calculus. So I never actually seen like a free response problem where you can simply plug in this formula. No, but however, that being said, the trapezoidal problems are actually pretty easy, as I would think, because once you get the idea, you're just adding areas of trapezoids up. You just have to make sure you understand what the trapezoid is in terms of the bases and heights, and obviously the context of the problem. So that's why, again, say we don't usually want to memorize this formula. Now we'll start off with going over a problem where we have equal widths or equal heights, and then I'm going to do an example. I'm going to do an example of problems that'll be on the AP exam where they won't have uniform trapezoids. So let's go through this problem here. So right now, okay, so we're going to estimate the area under the curve y equals 1 over x from x equals 1 to 2. And we're going to use the trapezoidal rule with 5 subintervals. So let's try to sketch up what this would be. 2. And we're going to divide in 5. Or 5. Okay, so if it doesn't specify that, you know, that you're not going to have the interval widths, then just make them all equal. So each of these will have a width of 0.2. 1 divided by 5 is 0.2. So this will be 1.2, 1.4, 6, 1.8. Now, when you're doing these problems, I really recommend draw a picture. Take the time to draw a pretty picture of the trapezoid and the sketch and show it visually. Don't be lazy. Don't be one of those lazy students. I have these every year that just want the calculation and they'll just because they don't want to do the extra work and they end up actually confusing themselves and taking longer on the problem than they would if they just drew a nice picture at the beginning. Plus, you're not going to understand it as well if you don't draw a visual. So really draw a visual. Take your time to do it. It's going to pay off. And you're going to actually see these are actually very easy problems. I would actually say these are the easiest free response problems on the AP exam. Once you can understand this simple principle, they really don't get much harder than this. Now, let's break this down. So the area is going to be approximately equal to A1 plus A2 A3 plus A4 plus A5. Now, A1. Remember, so again, let's think of it with what's going on here. We have the base 1 here, we got base 2 here, base 3 here, base 4 here, base 5, let's be base 6. And the heights are all the same. This will be the height. Height. So it's for A1, let's jump to the next one. The area of A1, remember, it'll just be the height for H. H will be 0.2. Let's write 0.2, and that'll be H times B1 plus B2 divided by 2. Now, B1, remember, this will be the value of Y at X equals 1, because remember, this point will be, pencil is driving me crazy. There you go. So this will be at 1, comma, f of 1, or 1 over 1. So just be 1. This will be a 1, comma 1. This will be at 1.2, comma f of 1.2. 1 divided by 1.2. I gotta repeat in decimal. 0.83 repeating. This one will be at, this next one will be at 1.4, comma, f of 1.4, 1 divided by 1.4, 0.712585. This next one will be 1.8, f of 1.8, or 1 divided by 1.8, 0.55 repeating. Its last value will be a 2 f of 1 over 2, or 0.5. That's 1/2. Do that ahead. Do that ahead, because then this will make the rest of the problem easy. Because now you already have all the heights or the bases. So A1, B1 plus B2, B1 plus 0.83. 0.83 repeating. Divided by 2. That's your A1. Now A2, let's switch the color here. The height will stay the same, so 0.2 times B2 plus B3. B2 will be 0.833, 0.83 repeating, plus this number, 1 over 1.4, plus 0.71428. 2857143. They're like right. All right, now A3. Height's still the same. Height 0.2. A3 will be then B3 plus B4. B3 will be this number again. Same thing again. 0.714257143. Like cool. B4 will be. Wait, did I not do it? Wow, not skipped it. Let's worry. Skipped it, and now I'm skipped for later. So let's fill this point. That's going to be it. 1.6. 1 divided by 1.6, 0.625. So B4 is 0.65. All over 2. Keep on going. Our next guy, A4, 0.2 times B4 plus B5, so 0.65, plus the 0.5 repeating, all over 2. And the last one, A5, 0.2 again for the height, times A5 or B5 plus B6, so 0.5 repeating, plus 0.5, all over 2. Now you can notice, so this will help you gain some insight of why the formula is the way it is. You can factor out a 0.2 over 2 from all of them. You can actually go 0.2 over 2 times 1 plus 0.83 plus 0.83 plus 0.7143 plus 0.714, all that. So plus times 1 plus 0.83 repeating plus 0.83 repeating. Yes. I'm just going to do an approximation here. Fit it all in one line. So 0.174. 743 plus 0.714 plus 0.65. 0.65 plus 0.5 repeating. See if we can fit it all through. Plus 0.5. Right. Fit it all in one line. Yeah, that's what I get excited about. It's being able to do math in one line. It's a math teacher, that's what I do. Okay, so the reason I'm kind of expanding it like this is so you can see the pattern. See how like the one appears once, the 0.5 appears twice, but all the other bases appear twice. That's where this function, that's where this formula comes in. F of x0 plus 2 times f of x1 plus 2 times f of x2. You'll have every other base repeat twice except for the n ones. And you see n going back to the next, and then you can factor out the b minus a, or the, you know, the interval width, which is the 0.2 divided by 2n, or it's divided by 2. You know, that's what this is. And when you know, do the calculation, we get approximately 0.6956,349. Now, just a side note, I wrote these as approximate decimals here, just so just to kind of make sure I can kind of help you understand the concept. Usually, when I'm doing this doing a problem like this, I'm gonna leave all the function, you know, all the bases as a function, like still as like 1 over 1.6, 1 over 1.8, and then not compute it till the very end. That way, I get a more precise answer. In either case, you should get something around, you know, a little less than 0.7. All right, so there you go. Good luck. I hope that helps. It wasn't, wasn't,